The second question you ask is a pretty challenging question. So the guy needs to know in 40 years how much money he needs to have in order to live on interest only the rest of his life. Therefore, the future value here is unknown. And we want to know the monthly payment, like 40 years earlier right now, how much money he put in every month in order to reach that financial goal in 40 years. So we do not know the monthly payment as well. Monthly payment is the goal, is the question is asking. But we do know the future value. In the TI-84 calculator, here we have 40 times 12 because the annuity must have 40 times 12, that many monthly payment. Annual interest rate is 9%, so let me double check. 9%, so we put 9 here. Present value is always a 0 for annuity. Monthly payment is the value we are looking for, so I put a 0 here and I will go back in a moment later. Future value we don't know, so we need to figure out how much money we should put here. That's the key. Pretty challenging, this part. How do we find the future value for this annuity? In 40 years, the guy wants to have 80 grand simply just for interest for that year. So we need to find out what kind of interest in order for the guy to have 80 grand annual interest. So we need to figure out the interest rate. The tricky part is students use 9% right here as the denominator and end up with the wrong answer. Here the interest is supposed to be the effective rate. Effective rate is the last topic we cover in section 8.4, compound interest. This is the formula for finding the effective rate. On my table note, I have a picture, an image to explain the relationship between effective rate, APR and APY. APR and APY is something you hear often in real world. They are actually the same thing in essence. They are both the effective rate. APR is the effective rate when you are borrowing money. APY is the effective rate when you are investing money. They, in essence, the same thing. So R here, 9%, is the nominal rate. We use R equals 9% to find the effective rate for the annual interest. So we enter R equals 9%, N equals 12. We got a 0.09380 and so on. A long number. I do not round it until the last step. So this is the effective rate. Effective rate is about 9.38%. It's always bigger than nominal rate. And that's the rate we need to use for this formula to find the future value of the annuity. Future value of the annuity is gonna be the principal for the guy's retirement plan. So principal times interest rate gives you the interest, right? So interest divided by the rate would give you the principal. So we use the 80 grand. That's the money he wants to have every month to live on after retirement, to divide by the effective rate, and we have the future value of the annuity. So I did not round it. I enter this number in, let me see what is the number, A52815 right here. A52815. 0.75 Oops. So you enter that number and then you go back a payment, and you can try this on your own. You would have the monthly payment here. And I enter to your Pearson $183, and that is the correct answer. I'll let you practice more times in your Pearson to figure this question out. If you have any questions, feel free to ask me.